Hey there. We are in lesson 16, finding and interpreting inverse functions. Why are we doing this, right? So today we are going to find, hold on. I learned I can type. So today we are going to find the inverse of a linear function by solving an equation for the input value. Okay, so we're going to rearrange the whole equation so that the input value is all by itself. We're also going to interpret an inverse function in terms of the quantities in a situation. Okay, two things we're doing today. Let's get into it. So first of all, shopping for cookbooks, the warm-up. Lynn is comparing the cost of buying cookbooks at different online stores. So store A sells them at $9 each and offers free shipping. Store B sells them at $9 each and charges $5 for shipping. Store C sells them at P dollars each and charges $5 for shipping. Store D sells them at P dollars and charges F dollars for shipping. So let's write an equation to represent the total cost in dollars as a function of N cookbooks bought at each store. We've learned how to do this quite a while ago. Okay, so this should not be terribly difficult. It's not easy, but not terribly difficult. So total cost as a function of the number of cookbooks. So here it's like $9 for each cookbook plus $5 for shipping. Still, oh no, free shipping. That first store was just $9 per cookbook. Now we have $9 per cookbook plus $5 for shipping. Here we have P dollars for a cookbook plus $5 for shipping. And here we have P dollars for a cookbook and F dollars for shipping. All right, so write an equation to represent the total cost T in dollars as a function of N cookbooks bought at each store. So I guess for A, I just did this. Sorry, I didn't read well. 9N. For store B, we have the total cost as a function of the number of cookbooks is 9N plus 5. For store C, the total cost per cookbook is PN plus 5. And for store D, the total cost as a function of the number of cookbooks is PN plus F. Okay, cool. Now write an equation to find the number of books N that Lynn could buy if she spent T dollars at each store. So we want to write an equation where we have solved it for N. So here we have T, and let's actually do this. So it is T as a function of N, but we want T equals. Going to make it much easier to rearrange. And let's do part B. Oh, well that's awesome. Part B all in blue, or this is number 2. So if we're solving for N, we're going to have divide both sides by 9. Okay, we just divide both sides by 9. And that cancels those 9s out. Now for B, first I need to subtract 5. And then, so that's gone, and then divide by 9, the whole thing. Now we've done this in the past, and I will admit, some of you really got it, and some of you struggled, even with a retest. Okay, so let's do this again. We can do this. See if you can figure it out. Subtract 5 from both sides. Excuse me. And then divide both sides by P. So this would be T minus 5 over P equals N. And this last one, we're going to subtract. We're still solving for N, even though these are all letters, and they're so hard when they're all letters. And then divide both sides by P. So T minus F over P equals N. So that's A, B, C, and D. All right? All right, cool. Now, from Celsius to Fahrenheit, it's quite common in science for there to be an equation when you know that your temperature is in Celsius and you're trying to convert it into Fahrenheit. And it's this equation right here. So we know the temperature in Celsius. We can find the temperature in Fahrenheit using this equation. Complete the table with temperature in degrees Fahrenheit or degrees Celsius. All right. So when we know Celsius, it's very simple for us to, I wish I still had that cool calculator, to figure out the Fahrenheit. So I know when, we'll just do it here, 9/5 times C plus 32. Okay? So that is just 32. Now let's try the next one. 9/5 times C, C is 100, plus 32. So 100 times 9/5 plus 32. Okay, now for 25. 9/5 times 25 plus 32. Nine fifths times 25 plus 32. Right, now let's go the other way. Now when we know the temperature is 104, the Fahrenheit temperature is 104, and we're trying to find degrees Celsius, we're trying to solve for the C. All right, so at this point, I'm going to do a lot of algebra. I actually love algebra, I shouldn't scowl. So we're going to subtract 32 from both sides. And then divide both sides by 9/5. And I get C equals 40. Okay? That's a lot of work each time I want to find C. So what I actually want to do is, I'm looking ahead to number 2. The equation f equals 9/5 C plus 32 represents a function. So let's write an equation to represent the inverse function. Be prepared to explain your reasoning. All right? Oh, I hate it when that happens. Let me pause and fix that. I'm going to admit I got distracted, and then I thought I pushed record and kept going, and it didn't record, so I'm not sure where I left off, but I think I got it. All right, so the last thing I think I did was found, oh goodness, I erased it. Found the Celsius when the Fahrenheit was 104. Okay, I'm just going to do that one more time. 104 equals, so that's the Fahrenheit, 9/5 C plus 32. And I'm going to solve for C, which is a little annoying. I'm going to subtract 32 from both sides. Yeah, I already did this. I apologize. 104 minus 32. I can't rewind the video to see where I left off, so it's just not as easy as the program I've used in the past. Now I'm going to divide 9/5 from both sides, and I get C equals 72 divided by 9/5, 40. So 40 goes right here. Okay, that's kind of annoying. I'm peeking ahead to number 2. The equation represents a function. Write an equation to represent the inverse function. Explain your reasoning. So by explaining my reasoning, I'm going to show my work. I'm going to make that inverse function so I can use it, because it's a lot easier to solve for the input, okay, when that's actually the output. So I want to solve for C because my new input is Fahrenheit. So I want that C to be by itself just so it's easier to use. So I'm going to subtract 32 from both sides. And I get F minus 32 equals 9/5 C. Divide both sides by 9/5. And we got it. So I have C equals F minus 32. And then I did 9 divided by 5, and I know that is 1.8. Because it's just nicer to have a decimal there. So there's the inverse. Now I can use it for these next two values. So if I input 50 minus 32 divide by 1.8. I don't have to subtract 32 from both sides, then divide both sides by 9/5. I can just do 50 minus 32 divide by 1.8, and I get 10. And then C equals 62.6 minus 32 over 1.8. I get 17. Okay, it's just a lot easier. You do all the hard work once, and then the equation is there for you to use over and over again. Now, let's look at this next equation. Let's change colors again. It says the equation R equals 9/5 times C plus 273.15 defines the temperature in degrees Rankine as a function of the temperature in degrees Celsius. So our input is Celsius, the output is Rankine. Show that the equation C equals all of this defines the inverse of that function. So let's see. I guess I'm going to distribute this 9/5 first. So 273.15 times 9/5, which we already learned was 1.8. I get 491.67, surprise, surprise. So 9/5 times C plus 491.67. So let's subtract 491.67 from both sides. And I get R minus 491.67 equals 9/5 C. Now if I look, they've got 5/9 out there. So what I need to do is multiply both sides by the reciprocal. Oops. So what that does is it cancels those out, makes it 1, and then 5/9 out here. So that right there is the reciprocal without this in it. And it's much more useful. So that's the equation that defines the inverse of the function. All right. We would use that equation if we knew Rankine and we were trying to find Celsius. Just like we would use this equation if we knew the Celsius and we were trying to find the Rankine. Right? Okay. Hold on. We're going to do something with these graphs. All right, so what does the inverse function tell us? Okay, why do we do the inverse function? If we look up here, I'll circle them in red. We have our original equation and our inverse equation. Let's see, I think I can make hold on. I just like to be able to see both of those. Okay, that's our original equation and our inverse equation. Now we would use this one if we had a table where they were giving us all the C's, like here. If we knew what the Celsius was and we were trying to find the Fahrenheit, we would use that equation. Because we would input the C, Fahrenheit's already solved by itself. Now we would use this equation when we were inputting all the Fahrenheit values and it was spitting out all of the Celsius values. We'd input all the Fahrenheit values and it spit out all the Celsius values. Same with the Rankine and the Celsius. If our input was Celsius, we were trying to get out Rankine, we'd use this equation. And then the inverse one, if we're trying to input Rankine and spit out Celsius, we'd use this equation. That's what inverse equations do for us. Okay, info gap is very difficult to do on a flipped classroom. So we have problem cards and data cards. We may or may not do this in class. Okay, it's just, we may or may not. I will decide before class, all right? And that makes for our lesson. Yeah, oh goodness, it keeps doing that. And we're not going to do this. Okay, that makes for our lesson to be a tad bit shorter. Cool? All right.